I know Olivier quite well because we already did a conference together back in Paris. And I can tell you, like, this guy is very, very smart. Before Gradium, so Gradium is an AI lab. He will talk about that. But before that, he was at Google Brain for a few years. He was the kind of engineer writing papers, so really leading the field. And that's why I'm super excited to have you on stage. I know it's going to be awesome, and I can't wait to see your demo. Good luck, Olivier.
All right, thank you. All right, so let's do it. So I'm really happy to be here in Brussels today to tell you what we do at Gradium and the cool new stuff that we are building and who we are. Maybe to begin with, like, who has heard about Gradium here? Yeah, well, that's cool. I appreciate. Like, at the end of the talk, obviously, I hope 100% of you will have heard about it, unless you're asleep. So who is Gradium? So we started last year in 2025, and we gave ourselves the mission to be the voice foundation layer. And by that, it means that we're building a foundational model for voice to enable natural and real-time conversation at scale. And you may think that, yeah, we're kind of babies on this market because that was just not even 1 year ago. But in terms of track records, we have a long track record in the field of speech and especially in the research community. So we are a spin-off of Kyutai. I'm not going to ask you again, but I'm going to tell you it's a Paris-based non-profit open science lab that was founded in 2023 with 300 million euros of donations. And in the time frame between 2023 and 2025, a number of actually breakthrough has been brought by Kyutai. Maybe the most famous one, if you don't know, go online and check it out. It's pretty impressive. That's Moshi, which is the first full duplex speech-to-speech dialogue system. Also has been Hibiki, which is a real-time translation model, and Unmute, not the first one, but a voice native layer for any LLM architecture. And those were 3 milestones in speech, and we said, okay, let's take this leap of faith and do a 4th one, which is go from from research to product, sorry. And that's why we raised $70 million last year to start Gradium. So what do we do? I believe any kind of serious player on this market has to know about its basics, which is speech-to-text and text-to-speech, TTS and STT. And of course, we offer that through our API, and that's powering all the cascaded models running in voice agents today. But we also do things that are a bit more unique, I believe, or ahead of time. We offer like TTS, text-to-speech and device. I'll talk about it later. And also our first speech-to-speech API for real-time translation, and I'll try to demonstrate it later. Spoiler alert. All right, so you might be yourself in the position of having to choose, or maybe in the near future, to choose a TTS provider. And there are a bunch of them out there. So I'll help you, find the good criteria to get there, right? It's important, and maybe you'll draw your own conclusions, right? So I think there are 4 properties you should look at: reliability, latency, voice quality, and scalability. So let's go by part. In terms of reliability, I think that's the most important one by far. Basically, you want the text that you give as input to your system to be properly pronounced. If it's mispronounced, it can be okay, but sometimes it can be totally wrong, right? If you mispronounce a tracking ID or a birth date or social security number, whatever, this is wrong. So we assess this. Actually, we do not assess this. We let external benchmarks continuously send us requests, us plus a bunch of other actors on the market. So it's quite crowded, as you can see, with big names. And they measure the amount of errors in the produced audio, right? And we're really happy to be ranked first on this benchmark. So we have basically, at the moment, the most reliable TTS on the market. And usually those benchmarks, they're only focused on English, which is a bit of a bias somehow, because a lot of the data are English, a lot of the focus in English, but not all the world speaks English, and AI should democratize, and respect the different languages. So at the moment, we offer 5 languages, and we also benchmark ourselves against the competition, and we constantly, outperforms the competition, which is very important for localization. Now you can have a very reliable TTS, but if it's slow, you can forget about it if you want to plug it into your voice agent, because it's going to ruin the experience. And so here that's also the Koval benchmark that I mentioned earlier when I added a second dimension, which is ranked by word error rate. And look at the first column here, the latency. What you can see here is most of the actors, they are either fast or accurate. And we believe that we're one of the few that are both fast and accurate. That makes it quite useful to be used in the voice agent. All right, so that was for reliability and latency. Now, in voice especially, first impression lasts, right? So if it doesn't sound good, you may be super fast, the impression is totally ruined. So we're specifically working and with a kind of scientific method to address this very subjective problem. I'll give you just a quick example out of...
I've been thinking about it, and honestly, Mondays don't deserve all the hate. Tuesdays are way worse. Nothing good ever happens on a Tuesday.
Right, but this event, obviously, but the voice looks, sounds quite good to me. I'm not a native American speaker, but this is the kind of voices that we can craft. Another aspect of voice quality is voice cloning. So here a quick disclaimer. This is not a partnership with those people, but if I cloned my mother's voice, you would not recognize anyway. So it's a voice of famous people, and just for the sake of this presentation. So if you put voice cloning into your products, make sure you have the right to do so. So now let's just listen to it. Oh, sorry. A little bit. How do we do that? Oh boy. Yes.
And have you seen what Gradium is doing with voice cloning? It's kind of crazy, like seriously. You record like 10 seconds of your voice, that's it. And the system analyzes the tone, the pitch, the accent, all those little quirks that make your voice yours. Then boom, you type text and it talks back in that voice. And it sounds real. You know what I mean. Like the little rasp, the breathing, the pacing,
okay,
all that stuff is...
The idea is that you actually, as was said, you take a sample of 10 seconds and you're going to reproduce all your voice artifacts. And when we compare ourselves on a blind A/B test against one of the famous competitors, which is actually known to be really good at it, we, in average, outperform them. All right, and the last one, again, scalability. So scalability is important because you can have a very good system, but if you cannot apply it to your industry with all the constraints that you may have, then it's a bummer, basically. So we offer our system through Cloud API, can have dedicated instances, self-hosted on your infrastructure in the private cloud, on-premise deployments, available through marketplaces, and we're in Brussels. We probably should talk about Europe and EU data residency, so we can ensure this, of course, for you. So far, what I'm showing you is somehow nothing new, right? TTS, we didn't invent it, it exists, there are other providers. So what I'm going to try now is, we like it a lot at Gradium, is to do live demos with all the risk and no safety nets. So I might fail miserably, be prepared. But we are also bringing like new stuff and new cool stuff on the table. So one is live translation, which is a very early model, private beta, and there are actually 2 models. The first one is the speech-to-text translate, which is a single model that's transcribe and translate at the same time. It can be fine-tuned for specific vocabularies. And the second one is the speech-to-speech translation, which is plug it, a TTS at the end of it, and you have a system that translates in real time, which is not full cascaded, like speech-to-text, LLM, text-to-speech, but only 2 models that are much faster. And I insist on this one, it's optimized for long-form content delivery. You might find other actors out there that after 30 seconds, 1 minute, 2 minutes, like it stops translating, or it totally diverges because of the context, which is too small. Here it's made for, somehow a very long content. All right, so demo time. That's the moment you fear more than I do, maybe. All right, so what I'm going to do, and we'll see if the acoustics helps us or not, I'm going to say a couple of words in French, and I'm going to translate into English directly. Okay, let's go. Bonjour, je m'appelle Olivier.
Hello, my name is Olivier.
Et je suis très content d'être ici à Bruxelles
I'm very happy to be here in Brussels
pour vous présenter notre nouveau modèle de traduction instantanée.
to introduce you to our new instant translation model.
C'est un modèle qui est disponible en 5 langues.
It's a model that is available in 5 languages:
Français, anglais, portugais, espagnol, allemand.
French, English, Portuguese, Spanish, German.
Vous pouvez l'utiliser et l'essayer par vous-même.
You can use it and try it yourself.
Pour cela, il suffit de m'envoyer un petit message ou de nous écrire à travers notre site internet.
For that, just send me a short message or write to us through our website.
Merci Bruxelles et merci de nous avoir écouté, mon
Thank
traducteur
you,
et moi.
Brussels. And thank you for listening to me, my translator, and me.
Thank you. All right. Thank you. So now let's do another one. So here I was waiting for it to say it aloud because first, I'm not good at speaking when somebody else speaks. And second, it would have been like really bad for you to hear me and my translation at the same time. Of course, you can put the voice you want in there. It's going to be fun to put my voice. So just to see that the flow can keep going a bit more naturally, I'll do only transcription. And just to put a bit more spice in it, I'm going to try to change languages in the middle, right? And act as if I was doing a book table in a restaurant. So, let's go again. Opa. Bom dia, eu queria fazer uma reserva para 2 pessoas essa sexta-feira, dia 27 de junho, às 17h45, por favor. Ok, et maintenant, je vais parler en français et je vais vous demander un truc spécial. Je vais courir un marathon le lendemain et j'aurais aimé savoir si on pouvait avoir des portions un peu plus généreuses en glucides. Voilà. Mon nom pour la réservation, c'est Jean-Michel Petit, P-E-T-T-I. Attention, ça ne s'écrit pas comme on croit. Et si vous pouvez me confirmer par téléphone, au 06 32 45 18 64. Merci. All right. All right. Thank you for that. So that was an example that you can use it in a more agentic context. So that was my fallback in case I failed miserably. We can skip it. Last thing I would like to show you today is another different thing we do is Gradium Phonon. And I think it's kind of a game changer in the field, or soon will be. It's a TTS, so text-to-speech model, that can run on device. So it doesn't need GPU. It can run on a CPU. And I will show you it runs on this MacBook Air with an M4 chip. It runs on Raspberry Pi, Android, Apple, anyone. And you know about the GPU shortage today, and this really opens new horizons, right, for voice technologies. It also supports personalization and the same languages, right? If we compare us with the other actors out there, we see that our word error rates, reliability is also. That's a different benchmark, but much better than the competition, or at least better. The speaker similarity, which is how much similar the audio generated is to the input of the voice cloning, it's also much better than the competition. And the number of weights, which is not per se an objective. What is the objective here is to make sure that you don't have too much of a big model so that it can, doesn't need so much RAM to run. So here we have about, a couple of hundreds of million megabytes of RAM being used. So it can really be run anywhere. One thing to observe here is that the list of competitors is very different from what you saw before. And the reason is that the models behind are totally different. So it's important to say that it's not just you master one model and then you can put it on CPU. It's a full, research, open research project that we went through. And it really unlocks a certain number of applications. You will have your own ideas, but in gaming, customer experience, in robotics, automotive, wherever you have a device, but you don't want to connect to the internet, or when maybe it's too expensive, then it's really at scale, like changes the game. A quick demo here. This is running on my laptop. See, you can actually see the code running. That was not it. So it's just a simple app, C localhost. There is no port forwarding towards a B300 GPU. It's really running on my laptop. And
hey, Brussels, are you off the radar?
yeah, whatever. I mean, let's just write something with the voice of Darth Vader. And what is worth noting is the time to first audio is crazy low. Much lower actually than what we get on the API because the model is very tiny, and that makes it like it's kind of unbeatable. Like 20 milliseconds, you won't go to 0 anyway, but it doesn't matter for live interactions. All right, so maybe out of time, so I'll just wrap it up. What's next for on-device? We're soon going to release the STT on-device, which means we'll have the full stack. Full voice stack being able to run on device will be something big, and of course you can join the private beta, write to us, and raise your voices. Thank you.
Thank you, Olivier.
My pleasure.
It was amazing. A nice demo.
Thank you.